So now that we're familiar with what you can do with attributes, let's take what we've learned and do something a little more interesting and practical. We're going to be doing a medical simulation of what happens to red blood cells as they travel through the circulatory system. So let's start by opening up our red blood cell file. So we'll go to File, Open, Red Blood Cell, and take a look at what we have. We've got a couple pieces of geometry already in the scene. First, we've got this red blood cell. It's just, that classic little inner tube shaped, squashed beanbag thing. And this is the model that we're going to be using. We're actually going to do a particle simulation of red blood cells, and we're going to be copying this model onto all of the particles. We have this curve here, which is going to serve as the path for the particle simulation. And there's one more piece that we actually need to import. So let's go ahead and do File, Import Geometry, and we will import the heart and lungs. So there we go. We have the lungs model and the heart model, and now it makes a little more sense. Keep in mind, this is obviously not an anatomically correct model of the circulatory system, both in scale and layout. So what is our end goal here, and what steps do we need to take to get there? So have you ever seen those drawings in children's health textbooks that show red blood cells losing their oxygen, becoming blue, then passing through the lungs to become red again? That's the look that we're going to achieve here. So if you haven't seen it before, you're about to. The first step is we're going to set up a particle simulation. Don't worry, it's going to be pretty simple to follow along since this is, not strictly a particles lesson. And then when that's set up, we're going to copy the red blood cell model onto each particle, as previously mentioned. Next, we're going to be creating geometry for the cross-section of these arteries, veins, and capillaries here. We're going to give them a red or a blue color depending on what part of the circulatory system they're at. And lastly, we're going to learn about one final attribute function called the transfer attribute SOP, and it's going to help us transfer attributes from the tubes to the red blood cells. So let's go ahead and get started. First, let's make a new piece of geometry for the red blood cell simulation. We're going to do that by making a new geometry node and placing it into the scene. Now this is something we've never made before, and actually let's just go ahead and hide the red blood cell, the heart and lungs model for now. Oh, it didn't go away. Oh, here we go. We're going to go ahead, make sure that the red blood cell, the heart and lungs model are hidden. And if you'll notice, the heart and lungs model is still here when we have this geometry node made. So we've never actually made a geometry node before, so if we double click in it, let's look at what it does. It's actually just a file node, and it's trying to guess at what geometry file we want to read in. In this case, we actually don't want any geometry file at all. It's trying to guess at that heart and lung model, or depending on how you've had your file paths set up, it might not try to create that model for you. So if you get something that just looks like a square maybe, or like a cube in the middle, and you don't see the heart and lungs, don't worry, that's not an error. It's just how Houdini's trying to maybe not so intelligently guess at what it thinks we want. So we actually just want this empty geometry node here. And inside it we're going to put our particle simulation. We've made geometry nodes before by dropping in a box or a sphere into the scene, and what that does is it just creates a geometry node, but then inside, instead of being empty or having a file node, right, it's got a box or a sphere node. So let's go ahead and name this. We don't want to call it Geo1. We'll call it Red Blood Cell Sim. This is where we're going to do our particle simulation. And let's dive inside. Again, make sure you've deleted that file node since we don't need it. We want to set up a particle simulation But when it starts, the red blood cells should, more or less be evenly spaced out throughout this circulatory system path that we've got. So let's just reference in the particle path, and we'll use this to birth the particles. We couldn't use it to birth it right now because the particle path is right here, right in the scene view, and we actually don't have it here in our geometry view, even though it is visible. So what we need to do is we could do a couple different things. We could copy and paste we could go in here, copy and paste the particle path, the different lines, but we're actually just going to use a new node, and it's called a object merge. And this will just bring in any object from other parts of our scene into the geometry view so that we can do things with it. And the object that we're going to merge in here, if we just click on this little button over here to the right, we can select which object we want. We're going to pick the particle path and hit accept. And now, maybe to more easily see this, we'll turn off the old particle path. And you can see that we've got the particle path intact here. So now we need to make some particles, something we haven't ever done before. So to make particles, we need to drop in a pop network node. You'll see there's two kinds here, a pop network and a pop network old. The pop network is for the newer versions of Houdini, and the pop network old is sort of like set up for the old versions of Houdini. For this, we're going to be using the new one and not the old one. But if you're ever following along with, maybe some older videos out there for Houdini, and you notice that the popnet looks a little different, try checking out the popnet old, and maybe that might solve some of your problems. So, but with this new popnet, we are going to take the first input and connect that object merge into it, and turn the visibility on, and hit play, and let's see what we get. We have a bunch of particles filling up this path. A ton of particles filling up this path, actually. We don't really need that many particles, and that's really not the behavior we want, right? If we go back to the first frame and zoom in a little bit here and hit play, we can see that, every single frame we're spawning a bunch of particles. For the red blood cells, though, we kind of want all of the particles to already exist on the first frame, and then we don't want to make any new ones as the simulation plays. So let's fix that first. We're going to double click on the pop net and go inside. So just like a SOP is a surface operator, a pop is a particle operator. So don't get confused by all the shortcut acronym names here. Anytime you see the word pop, just know that it's talking about particles. And as you see, down here in our network view, we are in the dynamics level now. So what do we got here? We have a few nodes. For the most part, we don't need to deal with any of them except for one now, and then we're going to look at one later. So right now, we need to look at the source first input node. And this is going to be, it's going to control how our particles are born. So if we go up here to the birth tab, we can see two different ways of making particles. We have impulse, which births the exact same number of particles every single frame. And then we have, constant birth, which births particles over a period of time. Well, since we want a bunch of particles or red blood cells to be there on the first frame, and then nothing for the rest of the time, constant is probably not what we want, so let's turn that off, and instead we're going to use impulse. So we've got two parameters here, activation and count. Activation, if it's 1, it's going to birth the particles on that frame, and if it's 0, it's not going to birth any. So making sure that we're on frame 1 here, we are just going to alt-click to create a keyframe here because we want it to birth particles on the first frame. Then we'll advance 1 frame forward to frame 2, and we'll take the impulse activation down to 0. So now if we scrub through on our timeline, we can see that the impulse activation stays at 0 and it's only on frame 1 that it's 1. So what that's going to mean is it's going to birth a bunch of particles on frame 1, and it's not going to birth any more after that, which is exactly what we want. Now, it's not birthing any at the moment though, and why is that? It's because our impulse count is at 0. So impulse count, as you can probably guess, is the number of particles that are birthed each frame. Let's go ahead and put that at 100. 100 particles, as you can see here, it's a pretty good amount of particles. It scatters it well enough that we can see what's going on. And it's really important to make sure that we don't put too many particles, because once we copy that red blood cell model onto every single particle, if we got a ton of particles, it's really going to make the simulation run slow. Remember that whenever you're working with a particle sim or something like this, you can always work with a low number of particles to test, and then turn up the number near the end when you're ready to render. So I found that 100 is a pretty good number when I was testing this out prior to recording the lesson, so let's go with that. If we hit play, we can see that there's 100 particles here on the first frame. But then, they're not going anywhere. We want them to follow along this path. They're not even moving at all. So we need to make it follow the path that we have drawn out for them. So let's pause it here. Go back to the geometry view here. And then we're going to select the particles. So select the pop net. And then up here in the particles shelf, we're going to select curve force. So click on curve force particles. Looks like a little tornado icon. And then if you notice at the bottom of the viewport in blue, it says select curves for curve force particles, and then press enter to accept the selection. It's brought us out to our scene view. So make sure to click on particle path and then hit enter. Alright, there we go. Now when we hit play, we can see that our particles are moving along the curve, more or less. So you probably have a couple questions though. First of all, what is this giant red thing? This giant red tube is just the radius from the curve that the force is going to affect these particles on. Meaning that the force that's pushing these particles, it's affecting the particles as long as they're within the diameter of this circle, and then once they exit it, it's not going to affect them anymore. In our pop network, if we have curve force particle path selected, go to make sure you're on the curve force tab, and this max influence radius, that's what the red curve is visualizing. So you could change it to like 5 and it would be huge. For now, let's just leave it at 2. This default is actually pretty good. You want to make sure that there's not a ton of intersection, right? Because if the force here was, or if the radius here was 5, and then the particles moved into this sort of area where the forces are overlapping, it might, skip, not go to the lungs, go straight to the heart, and that's very bad for your health. So we'll leave it at 2. And if you're having trouble seeing the particles, which I personally think is a little difficult to see, we can go to the guides and uncheck show guide geometry, and there we only have the particles and the curve visible, but then the particles are still moving along the curve. Okay, so the next thing we need to address is that the particles are going in the wrong direction. They're going to go from this, where the heart is in the middle, through the capillaries back up to the lungs. I suppose if we were doing it like this, everything would be fine, but it's not set up that way, and our red blood cells are moving in the opposite direction. So if we go back to the curve force and scroll down to the tab that says individual forces, we've got a couple different things we can play with here. The first one is the follow scale, and that's the force that pushes the particles to follow the path. The speed of 1 is okay for now, but if we want to send the particle in the opposite direction, we need to change the scale to -1. So this will keep the speed the same, but now instead of moving it, in the wrong way, it's going to move it in the right way. Also, you might notice I've got my timeline down here set to a pretty large range, and that's because I think the default of like 100 or so isn't going to give us enough range on the timeline to actually see what's going on with our particle sim. So one step you might want to take if you've never done this is down here. There's a box that is the Global Animation Options button. If we click it, we can see that our animation is set to 24 frames per second, and we can also set the start and the end on the timeline. So just change the end to something like 2000 or 2100, and then set apply, and then close it, and you'll see that the frame range has increased down there. We don't really need quite 2000 for this, but it never really hurts to have too many. So okay, if we watch the sim, wow, even right at like frame 100 or so, we're noticing that particles are maybe kind of flying off course here in the middle. We really don't want them to do that. See, this one right here has just left the track, and it's flying through the air, and it's not sticking with the curve. We really don't want that to be happening. We need to change this suction scale so that there's a stronger force pulling the particles to the curves. So again, I played with this a little bit too before recording the lesson. I found that a pretty high value, like 5 or so, will make them stick better. Since it's been playing, you can now see that the bar that's showing my cache down here is turned orange. That's because I've just changed a value here, and that means it needs to be replayed to bake again. So now let's hit play and see what happens. You can see that as the particles are trying to escape, the force that's pushing them back on to be on track with the curve is a lot stronger. It feels a little more elastic actually as it hits those corners, and it's just going to make sure that any type of place where there's maybe a tight corner, that the particles aren't going to escape its path and they're going to stick. Be careful about putting it up too high. For instance, if we put it up at something absurd like 50, the motion's going to get a little erratic. As you can see, the particles jitter back and forth. So it's a bit of a balancing act between the follow scale and the suction scale. For now, 5 is okay. We could always change it later if you needed it anything different. So, okay, our simulation looks pretty good. Let's turn our particles into red blood cells, because dots are boring to look at. If we go back up to our geometry view, again, just hit play, confirm that everything's working fine. It's a little easier to see now that the line for the curve path is gone. To change the particles into red blood cells, we're going to use a copy node. And if you remember from last lesson, this is the same node that we used to make the different arms on the chandeliers, only instead of using an expression to copy them evenly spaced, we're going to copy them to each location of the particle. So we're going to do another object merge, because remember, we need to reference in that red blood cell model that we've got up here at the scene level. Oh, there we go. We're going to bring this in, but again, since it's at a different level here, we couldn't actually copy it on here. without merging it in first. So we'll make an object merge, and from the object list we will choose red blood cell. Hit accept. We can see it in here. That's good. We're going to do a copy node, and we are going to, let's see, make sure I don't get this backwards. Oh, I got it backwards. Huh. That's not what we want. Let's just order this a little bit better. The first input will be the object that we're merging in. Let's just rename this. Right now it's called object merge 2. Let's call it blood cell merge. And the other merge, we'll call it path merge. There we go. So blood cell merge is in the first copy input, and then the second copy input will be our particle network. If we put the visibility on, hey, we've got red blood cells instead of particles. And you can actually play that back, and not only do they follow the path, they're tumbling along, and it actually looks quite nice. There is a few problems with the blood cells penetrating each other, and we could fix that if we needed to, maybe sometime later. For now, we've got a pretty good visualization of what's going on, and it looks pretty good. Now, if it's running slowly on your computer, again, that's probably just because there's a ton of models here now. A couple things you could do to fix it would be to use that poly reduce node here on the blood cell before it gets copied onto each one of the particles. And of course, the second option would be to not birth so many particles. But it really looks like 100's a pretty good number here. So if you have to do something to save on resources, I would reduce the poly count. Or you could even forego using this blood cell model and then instead use something like a sphere to represent a red blood cell until you were ready for the final effect, and then swap out the sphere with the blood cell. So this looks pretty good. Next we need to make this curve into like the tubes, into the arteries and the veins, and then these capillaries down at the bottom, so that the blood cells have something that they're traveling through and not just empty space, right? Because right now, if we turn on our heart and lungs and hit play, it's kind of nice, but the red blood cells are just traveling through space, and that's creepy. So, okay, we actually know how to do this already. This is the same way that we made the arm for the chandelier. So let's go ahead and make another object merge. This time we're going to merge in the particle path. Remember, we need to have a sweep node and a skin node in order to make that tube. And we also need a circle. If this seems a little fast, you might want to go back to the last lesson and brush up on the steps here. Just remember that the sweep node is going to copy this first input, every so often onto it, and then the skin node is going to connect all of the pieces that we've swept across. We're not actually seeing that tube because, again, we need the primitive type of the circle change to be something like a polygon. Okay. Now you'll notice pretty quickly that this doesn't work, and I did that on purpose. We need to do something to fix this weird stretching that's going on, and you're probably wondering, why is this weird stretching going on? Well, that's because this particle path here is actually made up of several different curves. So if we look at it here, we've got a curve Oops. Let's turn off the heart and lungs and the red blood cell here. What did I do? Let's turn off the blood cell simulation. There we go. Okay. There we go. So we have a curve down here. We've got the main path, and then we've also got this other curve that are all being merged together here to, right, we have the main circulatory system, but we kind of needed a couple of branching paths here to make the simulation look a little nicer. And the end caps, or the end points of these different curves are trying to all sort of connect to one another when it's doing the sweep node. And so we need to do something to fix that. Let's just make sure that the last transform node is selected here. Okay. Back into the red blood cell sim. So unfortunately, we're going to have to get rid of this and do the sweep in the skin a couple of different times. But that's actually okay. It won't take too long because we can go back into the particle path, do Control C to just copy everything, go back into the red blood cell sim, maybe give us some space over here to the right, and paste the network in. Hide everything else for a minute while we're working. And so we can see here that we've got this same network of curves here. So we've got them merged right now. We actually need to take the merge away and then and make them into 3 separate tubes and then merge them back together again. Also, if you'll notice, there's a transform node here on the end, and it's set everything to a uniform scale of 50. That's because the heart and the lungs model are pretty big, and originally when I drew these curves they were a lot smaller, so I had to scale them up to fit. So we're going to delete the merge node. Oh, did I delete everything? Delete the merge node and the transform. Organize these a little bit better. Just spaced out maybe a little more nicely. And then we need a transform node with a uniform scale of 50 after each one of these. Or, you know, we could do it at the very ends too. But I find it a little easier to do it like this. So once you make the first one, you can just copy paste the new ones and connect them up. Whoops, selected the wrong input here. Make sure that each of these looks good. Okay. So let's add the tube geometry now to each one of these separately. We'll do the main piece first here, so we will add a circle and a sweep. I'll zoom in here. I sometimes have a habit of working with the node graph being a little too small, but that doesn't work very well for a video. So I'm connecting the transform for this curve into the middle input of the sweep, and then we're going to connect the circle into the first input, and then we're going to add the skin. Again, the circle needs to be like a polygon, and if we view the skin, now we can see the tube. There's a couple of problems. First of all, there's this little hole here. We can fix that in the skin by changing VWrap to on. And then, let's see, there's also, remember, if we add a resample node, we can get rid of these really hard edges here. So we're going to put in a resample after the transform. Ooh. It's connected it up a little weird, so we just go back here, give us some more room. Now we'll drop in a resample, connect it before the transform, make sure not to hit the circle path. And there we have it, a much smoother tube. Now that we've got that all hooked up, we can just copy the resample, the sweep, and the skin, and hook up the other two curves the same way. So let's just go ahead and copy and paste this. We need to hook up this resample not to the previous transform, but to the new transform down here. And it's got a weird stretching problem again. Now that's actually because we copied this skin node that had VWrap set to on. Since this tube isn't going to be, a complete path like in a circle like the old one was, we need to make sure that we turn VWrap off, and it will get rid of that ugly piece down there. And then one more time, we'll just copy and paste this whole thing over again, disconnect the resample node, and then reconnect it back to the new transform. Make sure that this circle node is connected to the first input of all three of them. Sometimes if you move groups of nodes around, it's really easy to do what I did a minute ago and accidentally mess up the connections between one or the other. So just give it some space, spend some time spacing out the nodes like this, and make sure that your connections are going to where they need to. So finally, we can add a merge to merge all of these tubes together. So if we turn visibility on for the particle simulation, and then we template the tubes and hit play, we can see that our red blood cells are moving along just fine inside the tubes. Couple of them are peeking out there a little bit. We could fix that later on by by lowering the radius maybe on the particle simulation, and then keeping that that suction force maybe a little bit tighter. But for now, we'll call the simulation good enough. But there is a problem, however. We can see the particles just fine doing this, but if we were to actually merge these now, we totally lose our particle sim because it's happening inside the tubes. What would be really nice is if we could do like a cross-section or a cutaway. Well, we actually already know how to do that because we did that with the dragon model. So we're going to use the position attributes on this tube in order to cut away the front half. Instead of cutting away on the x-axis, we're going to cut away on the z-axis. So you should be familiar with how to do this, so I won't go quite as slowly as before. But we're going to make a group. Again, we're going to want to do all of this on the tube. We don't want to do it after the merge, and that's very important. If we did it after the merge, we would cut off all of the red blood cells too. And right now we only want to cut the tube off. So let's look at this group here. Again, give it a name. Let's go ahead and call this Z negative. And we're going to group by expression. And we're going to call this $TZ is less than 0. So we're grabbing all of the Z points, all of the points that have a Z position of less than 0. And if we look at this sideways, we can see that it's cutting away the front half, or right now it's only selecting the front half. And then we add a delete, choose the Z negative, and we can see that it's cut away the front half of everything. So now we've got a cross-sectional view of our circulatory system. When we hit play, we can see the tubes, but we can also see the You can also see the red blood cells running through. Now I'm also just noticing how dark gray all of these tubes look, and that's because there are a ton of polygons. We don't need so many there, so let's go back up to our resamples here, and instead of a length of 0.1, change these to like a length of 1. That'll still be plenty of detail. There we go. Now we're going to give the tubes some color. So with this last delete node selected and everything visible here, we're going to select like the right half of these points here. If again, back referring to those like the health textbooks, they usually show the right half of the tube as red, and then when it goes through the capillaries they turn blue, and then the left half of the tube ends up being blue. So we're just going to kind of roughly select this. We don't want to use an expression to select just the right half on the z-axis, or on the x-axis, because that's a little boring. We want some variation. So go to select mode, make sure you are selecting points, and we're just going to click and drag and select a bunch of points here. Oh, this will be very important. So when I just did that marquee selection, you'll notice that I missed some points here on the back side, and that's because they weren't visible, like these red blood cells were covering them up, so they didn't get selected. Make sure that up here in the selection, you are by default it's set to select visible geometry only, and you want to deselect that for this because we don't want to leave anything out. Sometimes it's really useful, sometimes it's really not. It's just kind of all at a case-by-case scenario. With shift selected, we can select a bunch of points and keep adding to the selection. And down here in this capillary area, we'll go ahead and vary it a little bit. Let's add some more here. With the control key, you can deselect points. So just instead of a harsh line here, I just want to stagger the point selection a little bit. That'll be good. Okay. We want to make a group of these points that we had selected. Right? Previously we've been grouping by selection. Now we want to, or grouping by expression rather, and now we want to group by selection. So with everything selected, we'll hit Tab, type in group, and hit enter, and you'll see that we've made a group node. All of these are selected, and down here it's set to group by pattern, and it's just a big long list of points, which would be a pain to enter by hand, but since we've selected them, it's gone ahead and done all of the heavy lifting for us. We're going to go ahead and just call this group red points. We're calling this group red points because this half of the tubes are going to be red. So let's add 2 point SOPs. Again, I don't want to be too zoomed out here, so let's give ourselves some space again after the group node. And we're going to add 2 point SOPs. So the first point SOP is going to be coloring all of the red points red. And the second point SOP is going to be coloring all of the not red points blue. So point SOP 1, we want to select the red points group. Instead of keep color, we're going to add color. And we'll just delete the channels here and change the color to red. We'll add a second point SOP. Again, not doing anything we haven't done before. Again, instead of the red points here, we want to put an exclamation point in front of it to say not the red points. And we're going to add color, delete the channels, and we're going to set this to blue. Alright, that looks pretty good. We've got, pretty much what we were going for there. Now we're going to introduce a new node, and this is called the attribute transfer node. If we go back and look at our simulation as it's looking right now, currently our blood cells are floating and they're just gray. And what we want is, while they're in the red tube, we want them to turn red, and when they're in the blue tube, we want them to turn blue. So, how do we do that? That's going to be the attribute transfer node. So let's rewind here and add an attribute transfer node. So in the left side, we're going to plug in the red blood cells, just all the way up here in the copy. And then on the right side, we're going to plug in the points, or rather the tube, which comes out of that last point SOP. And check out what happened. We can actually, in this attribute transfer, uncheck primitives because if you remember, color is a per point attribute, and that's what we need to transfer here. And just by hooking those two up, it's already transferred the color attribute. So if we hit play, we can see our red blood cells traveling down, and as they cross the threshold here, they turn from red to blue. Now, how is that happening? If we click on our attribute transfer here and look at points, we have nothing selected here. But it's still transferring point attributes, and that's because it's guessing, and it's just done a really good job of guessing in this case. Normally, it's not going to transfer the point attribute probably the way that you want it to, so you would have to specify which attribute you want transferred. So we could specifically say CD, again, CD being the diffuse color. It's not going to change the outlook from what we see here, but you need to know that that's how you explicitly specify which attribute you want copied from input 2 onto input 1. And if we go to the conditions tab, we can actually play around with this a little bit. If we go back a few frames, or maybe more than a few frames, here we go. We can see that there's a point in which the red blood cells change from red to blue. It's a pretty harsh transition. It starts affecting half of the model at once, and that doesn't look very good. In our conditions, we can actually change this max sample count. Right now the sample count is set to 1, and it's sampling from this distance, so a distance of 10 units in Houdini. It's taking one sample at each vertex, and it's saying, hey, what's the closest color from the thing I'm transferring the attributes from? And on this side it's red, on this side it's blue, so it's turning this half of the blood cell blue and this half of the blood cell red, and that's why we get this ugly line. If we crank up the sample count, however, it's going to sample multiple times. So in this case, at 8, it's going to, each vertex, it's going to look 8 different times in different directions. And effectively what that does is it just kind of blends the color a little bit better, kind of like a blur function. So that instead of, very harshly changing from red to blue, the blood cell kind of goes through this more gradual transition. This looks a little bit more natural. And it'll do that anytime it changes from red to blue. Alright. One little thing here. Let's disconnect everything we had from our merge node. Rearrange everything here. When we plugged the the end of this of all these tubes into the attribute transfer, we've sort of lost the geometry here, so we actually need to merge the attribute transfer back with the tubes again. So attribute transferred from the onto the red blood cells, and then plug the tubes back in, and we'll look at the merge and hit play, and we can see our simulation, which is cool. But of course, you know, I'm picky, and I see another problem with this, and that is that these blood cells are really difficult to see. There's no contrast, right, because it's taking the color attribute, so the thing in the foreground is the exact same color as the thing in the background, which, if we're doing this for visualization, especially such a simplified conceptual visualization here, we should not have such trouble looking at the difference between the foreground and the background. So let's go back a few steps, and instead of transferring color, we'll transfer an attribute that we create ourselves so that we can color the tubes and the blood cells independently from one another. It'll still function the same way, but instead of directly taking the color, it'll take, you know, an attribute that we make. So it'll give us a lot more flexibility. So for now, let's delete this attribute transfer. Sometimes when you reconnect stuff like that, the merge node throws an error because, let's see, a mismatch of attributes on the inputs is found. You know, that's actually okay for now. It's not going to cause us any problems. We can untemplate that merge. We'll go back and look at that later. Okay, so we've deleted the attribute transfer. And the first thing we're going to do is, so I liked the color for the red blood cells. That was fine. The thing that I don't like, however, is the color of the tubes. So let's go ahead and change those right here in these point stops. We could go ahead and name them to tube red color, tube blue color. Okay, so the red color, instead of being such a strong red, let's take it down and make it a lot more pale. We'll do the same thing with the blue. Alright, that looks pretty nice. It still looks red and blue, but the colors are a lot more muted, and then when we have really bright red and really bright blue blood cells, they'll stick out a lot. Okay, so now that we have that we've recolored these tubes, we're going to need to make our new attribute. And this attribute is, right, it's going to be for the new color. And why are we making this new attribute? Well, when the red blood cells have oxygen, they're red, and when they don't have oxygen, they're blue. So we're going to make a new attribute called has oxygen. So we will make an attribute create node. And again, we're going to be putting all this stuff in before the merge. This attribute create node, we will call it has oxygen. And the default value can be 0, and we'll just leave it at 0 for now. That way it starts out as saying no, it doesn't have any oxygen. We could actually change the type from a float to an integer. It doesn't really matter. One way or the other, either way, both will work. So, okay, we've made has oxygen, and now we need to make a new point SOP. What we're going to do is we're going to set the has attribute, or has oxygen attribute for these red points to 1, and then the blue points, since they're not in this red group, will be at 0. Remember that we already have a group called red points, which by now is a little more abstract because it's It's kind of pink and not red, but it's still that same group of points we had before. Now, we're not adding color here like we've been doing in the past. We're adding our own attribute, right? We're adding the attribute we made before in the attribute create that was called has oxygen. But if we look down here in the point stop, there is no option here for has oxygen. So what we need to do instead of the standard tab is go over to the custom tab. And here we can put in any attribute we want. So for the name, we're going to put in has oxygen. Make sure that you keep your capitalization and the spacing exactly the same, or it won't work. And there's only one input here. It's got support for up to 4, and by default, all of them are. You could put a value in all of them, but we only need one value here, and that is to change it to 1. So we've selected all the red points, and we're giving the has oxygen attribute on it a value of 1. Let's go ahead and just confirm that by looking at our geometry spreadsheet. Give us some room, and we have this has oxygen tab, and over here we've got a lot of 1s and 0s. We can just select a group of points here, make sure they're all red, and change the view in the geometry spreadsheet to only show selected. And you can confirm over here in this right column that has oxygen is 1 for all of those, and then maybe select a chunk of the blue ones, and has oxygen is set to 0 for all of those. So cool, we've got that attribute set up correctly. So now we can make a new attribute transfer node. Attribute transfer. Let's disconnect this merge node. Plug in. Ooh, copy node's pretty far up there. You know what? Let's go ahead and grab this particle sim and just bring it down a little bit, so that we don't have to go quite so far to link up everything in the node graph. So let's plug in our particle sim. Again, we're copying from the right input to the left input, and this time, it doesn't know. Let's not only show selected. So this time it's passing off a lot of attributes here, and we don't really want that. So we're going to pass off the point attribute has oxygen. And again, we can confirm whether or not that's working. By turning on show only selected and then selecting a red blood cell that should have oxygen, which is over here on the red side. Again, those values are all 1, and then we can go over here and check out something that should have no oxygen, and indeed those values are all set to 0. So it looks like our attribute transfer for has oxygen is working perfectly. Now that our has oxygen attribute is confirmed to be transferring over correctly in the attribute transfer, we're going to add one last point stop. So drop down the point stop. Let's deselect everything here so that we can actually see what's going on. And in the point stop, instead of keep color, we're going to add color. Let's go ahead and delete the expressions in these channels. So for the, we want everything to be red if it has oxygen. So in the red channel, we can just put the value for, can't find my key here, has oxygen. And that looks like it's working. And then for the green channel, we want to leave that at 0. For the blue channel, we want the inverse of has oxygen. So we're going to do 1 minus $, has oxygen. And there we go. Now we can plug this back into our merge. And we can play our simulation again, and now you can see that it's working absolutely perfectly. The blue red blood cells are, they're blue when they're in the blue part of the tube, and the red blood cells are red when they're in the red part of the tube. And but we still have these two sort of separate foreground and background colors, and we were all able to do that thanks to transferring our own custom attributes. That about wraps it up for this lesson. The sky's really the limit here for what you can do with attributes, so play around, see what you can come up with, and I know you can do a lot of really cool things. See you in the next video. Take care.